Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So, comments mostly, and let's just do an overview again. You know, this is initiated years ago with a physics girl video. I haven't looked lately. She's still like whatever that is, completely inert. But anyway, physics vegetable. But anyway, so the idea is okay, you take a 5 mass vehicle going 10 velocity and you add 5 mass to it. So now you have a 10 going 5. And the trick is the thing you end up with has half the kinetic energy, even though it has exactly the same momentum. So, and there's no evidence of any heat or deformation. Now, the argument is if there were any heat and deformation, that is, when you added the 5, if you created a whole bunch of extra heat and deformation, it would mean that heat and deformation is momentum in the universe. The little pieces flying off or the heat or all of that has to be made out of something's momentum. You can't get that for free. And if you conserved all of the momentum, if you have 99.9% of the momentum, you can't have done twice or 4 times that amount of work in creating a bunch of heat and deformation. So if you start with 25 joules and you only know to 5, you can't blame something else because there's no source for all that extra movement in the universe. You can't create more movement. You can't create more energy. So that explanation doesn't work. Deformation doesn't work as an excuse for where the energy is that you lose, the kinetic energy. The simple truth, it's a momentum. Okay, anyway, then so Steve Mould makes this retarded video a few months ago, and nobody talks about it 2 months ago. And so I've made all these videos with his name in the title, saying Lever Paradox, which he titled it, where he makes this idiotic claim that the 2,000-year-old Archimedes law of the lever, that is the simple ratios that, one distance, two distance will decide. Basically, you can just multiply the distance, and that's the same thing as the velocity, and it is the same thing as the velocity. So if this moves 1 unit of distance, the same motion will be 2 units of distance there, doubling the velocity. And so it basically just an argument about conservation of momentum, frankly. What the hell is wrong with the end of that pen? Anyway, so he makes the assertion that if I did do this experiment, which I have done and Brozo has done to some extent, that somehow I'm going to get this one mass, okay, at 2 distances will not conserve momentum and somehow will not leave at twice the velocity. So if I put a 2 mass in with 1v, I expect to get a 2 mass out with almost the same velocity. Obviously, I lose some energy to the motion of the lever. So we know that you're not going to get all of it back, but you're going to get a substantial percentage. And so what goes in comes out. Levers conserve momentum. And their claim is, though, if I put the half mass, that is a 1 mass, 2 distances, is that it'll only go 1.4 velocity. So a huge degrade, 30% of the momentum lost. So it doesn't conserve the momentum. So I have 100 going in, and I'm only going to get 60 out in terms of the momentum. And theoretically, you could understand that the lever, this part of the lever, this half of the lever, for the 2 experiments would move exactly the same. For this to go twice the velocity, this has to move 1 velocity. So it'll move exactly the same doing these 2 different acts. So there's really just no logic to this argument that somehow the lever is going to know the difference, and that it's such a huge difference. So if you used your own finger to test, and I put the 2 mass at 1 distance, and I put a 1 mass at 2 distances, and you were trying to feel the differences in those 2 weights, those 2 experiments, if I put them side by side, you wouldn't be able to feel the difference, unless you bounce them. But if you just move them, it's a 30% difference. It should be obvious, and it won't be obvious at all. And anybody who's done anything like that experiment in life probably has noticed that. So, it's not very complicated. Just, put anything on the ground, and here you have a lever. Put a ruler on, and then put a weight on it there, put a weight on it out there, and then you can see that if I conserve the momentum, that is the velocity and the object's mass, I won't be able to feel the difference between a one mass at two distances and a two mass at one distance. And it's just a fact. They certainly haven't tested. Okay, so in all these hundreds and thousands of years of physics existing, they have tested none of this. They haven't, incrementally even just dropped an object on a scale. That's, such a simple experiment, and they haven't done it. Now, I have a scale. Okay, it's cheap, so this doesn't cost much. I found it in the garbage. And, that's actually in marks, and so then you could test it. First, see that, okay, it's accurate. And then you just drop things from 1 centimeter, and 4 centimeters, and then 16 centimeters. And you just keep doing that and seeing what kind of impact weight you get. They haven't even done that experiment. An experiment that simple, physics hasn't done. Because, frankly, what's going to be found out is that there's no difference between this and this. Okay. So you're going to get the same answers, okay, doing this as you're going to get doing this. Except in the case of where you take a mass that's very light and put it on and then do it this way at that same speed, you'll get exactly just one increment of its weight. The point being is that the same velocity will produce the same impact. So this is another experiment they haven't done. So I use the exaggeration of an elephant and a mouse. But, you could obviously do it with 5 pounds and 2.5 pounds. It's just 10 pounds and 5 pounds, or 10 ounces and 5 ounces. And you just push them into the scale at the same speed. Okay, have the object hit with a velocity, have its impulse, okay, measured. And the simple truth is that if you have them go at the same speed, the 5 mass will produce, the momentum will read the same for its actual weight. So if I have the 10 mass going in at 1 mile an hour, the prediction is it's going to weigh 10. And if I have a 5 mass going at 1 mile an hour, the prediction is it's going to weigh 5. They haven't even done that experiment. So, it's completely untested realm of physics. And it's elemental. So you can't get more elemental than the definition of energy. And the fact is their kinetic energy fails in so many ways. I've pointed out it never gets collected in a ballistic pendulum, fails every single time. I've shown the Bruce Yerney collision test where it never wins a collision. So you have 5 times more kinetic energy going into a collision. And if they have the same momentum, but there's 5 times the kinetic energy, the collision just sits there. It doesn't move. The kinetic energy doesn't do more work. Just a fact. It doesn't win the collision. It's just such an obvious, okay, it's obviously not there. There's energy not there. Because it can't win a collision. The most basic way to test something, whether it has energy, is to bang it into something and see what it does to the something. And the fact is it fails dismally. And momentum is obviously proven correct. And then the simpler even one is the whole rocket idea. You have a rocket ship and you want to move it. You move it by calculating the MV of the exhaust. If you calculate the MV squared, you won't get how much this moves. This is only going to move based on the momentum number. So whatever the momentum calculates to, you'll get the equal and opposite reaction. You won't get an equal and opposite reaction to the kinetic energy. It's nonsense. It can't do work. It can't obey Newton's third law. All right, so back to this lever thing. So the way I did the experiment was use a rubber band to create a constant force. So you didn't need this because you were creating a constant force. Prozo used a spring, same difference really. And the simple idea is that you just create tension in the rubber band, and and by pulling the thing back and or compression in the spring, and you get the same energy out for the same amount of distance you move it. Everything moves theoretically exactly the same for the two experiments, and when I did it, it seemed the results looked it certainly looked like twice the velocity. Now Brozo did it, and he got, for frame rates, the fast object was what was it, 10 and 19? I don't remember. All right, but it's pretty close. 11 and 19. Yeah, so pretty close to 2 to 1. Just a fact, not close to 1.4, clearly. So there was way too much energy in that light object. And so he promised he was going to do the experiment again because he wanted to gloat and prove me wrong, because he was going to have them roll or do some other kind of nonsense. And all of a sudden, nothing. Not even, I haven't seen anything. So did he explain somewhere where he copped out? Where his big proof that he was going to rub it in my face, his show me how I'm wrong and do all this bullshit? Where is it? So why didn't he do the experiment? Somebody have an explanation? Because I can't find it anywhere. I haven't looked that hard, frankly. I mean, the comment sections are... I mean, they keep using the phrase goofy, and, their comment section is goofy. I mean, it's childish shit. It's just terrible. Anyway, it's unreadable. It embarrasses you just to read it. All right, so I'll move on from there. All right, so over the past few years, couple of years, some things have been learned. I mean, things I didn't think about, didn't realize. There's something that's simple, is Galileo rolling objects down a ramp. And the question, the question would be, if you could see that. There, you can see that. So you roll it down a ramp. Now the problem is that its velocity at this point, is it going to be its free fall velocity, that is the velocity of it falling down, or did some of that energy have to be used to create its angular rotation, which still exists and is separate from the linear velocity? So I never thought about the fact that when a car is rolling, you could say the car has a mass, right? And it has a velocity going this way. But the fact is it also has these rolling wheels. So anytime there's some part of it that's rotating, that the fact is that's energy that can be collected. Now, if you bang a rolling wheel into a brick wall, the momentum is going to be in the downward direction. It's going to be pushing down when it hits the surface. The round thing is pushing down when it hits the surface, so it won't be impulse this way, it'll be impulse down. It'll tend to want to push the thing down, and the object will actually start rising up the wall. A human being can sort of run up the side of a wall if it gets enough momentum and blah blah blah. But anyway, so there is energy, momentum, angular momentum stored in the wheels. So if you measure just the mass and the velocity, you wouldn't know the total energy of the car, because you have to consider the wheels. So the heavier the wheels are, the more energy you can add when you hit something. So when a car hits something, it converts the round, the going in all directions, rotational momentum, and it converts it into momentum this direction. That's what the axle and the rest of the car does. It basically takes the energy of the rotating wheel and converts it into energy this way. So the actual momentum is the linear momentum plus the angular momentum of whatever wheels it's rolling on. So it's a real question. I don't have the direct answer for this because I've never seen it tested. So is the rotational energy part of, or is it added to? So if this rolling object coming down a ramp, if it has its free fall velocity, that is the velocity it would have if it fell from this distance, then it's also got rotational energy caught up in the angular momentum. So it's got more energy than just the free fall energy when it would hit something, depending on how it hits it. Again, it needs an axle to convert the rotational energy into linear in the same direction energy. So it's something I hadn't considered, something, and I'd say this is real physics. It's a real fact that this happens. If I use carts rolling on wheels to do experiments, I have to recognize that the faster the cart moves, the more energy it has stored in its wheels. So if I'm moving a cart at twice the velocity, I have twice the energy caught up in the wheels. So if the cart's actually going to velocity linearly, I have to add the rotational energy of its wheels as real energy it can deliver in a collision. So it doesn't have just its linear momentum, it has its linear momentum plus the angular momentum of the wheels. So the argument could be made is if you made wheels on a car out of lead, okay, and then drove the car at 10 miles an hour, and you have the other one with regular light tires, that the two cars will crash. The one with lead wheels will hit the wall and cause more damage because of the rotational momentum caught up in the lead wheels. Just a fact. You have to, this is a real variable, a real fact. They pay no attention. So the fact is in experiments, they'll do these experiments with these carts, and the problem is if the cart's going 2 or 3 times the velocity, it has a lot of angular momentum caught up in its wheels, especially if its wheels and axles are made out of metal and the cart's made out of plastic. It's a real argument that it's bad physics if you don't account for that variable, because it's a real variable. Alright, so another problem discovered was with springs and Hooke's law. So whenever they do an experiment to measure Hooke's law, what they basically do is usually tie the spring to a non-movable source, and then they'll have a mass that's stuck to it, and they'll oscillate it either up and down in gravity or side to side on some frictionless surface. And the fact is you can get it to oscillate with its energy back and forth, and it retains the energy and slowly loses it through friction. And so if you do it in gravity, it loses the energy much slower, and it'll oscillate for quite a while, bouncing up and down. And so it demonstrates Hooke's law. But the problem is that as soon as you use a spring and launch an object with it, all right, the catch is as the spring is releasing, it itself has a mass and it's moving a velocity. And the fact is it's going to have a mass moving the same velocity as the object it's pushing. And the problem is that as soon as the object's going its peak velocity and the spring is starting to decrease its velocity. The spring doesn't just push and then stop. The spring is going to start at 0. It's going to go to 5, 10, 20. Let's say 20 is the peak, and then it's going to go 19, 18, 17, 16. It's going to decelerate over a period of time. It's not going to decelerate instantaneously. So the spring's going to keep moving even though the object left. So the object's going 20, the spring is still going 19. So you can understand that. And if it's pushing something where it's only going 10 at the peak velocity, that is a heavier mass, then obviously at the point where the mass leaves, okay, it's going 10, the spring's only going 9. So now it's the same spring and it's only going 9 velocity. That means it's obviously got less energy still in it. And so the heavier the mass I put on a spring, the more efficient the spring will be in giving back the energy. And the lighter the object I put on the spring, the less efficient it will be in giving the object the momentum. So if I put a very light object, a piece of dust in front of a spring, the fact is the spring will retain 99% of the momentum will be stuck in the spring, and only 1% will go into the object. A tiny percentage. So those are the facts. So those are facts, again, I didn't realize. We had to have all these arguments and do these experiments before I saw the obvious finally. Well, obviously, if the spring is oscillating after the experiment, that it means it still has energy in it that it didn't give back. I can't push something into a spring, with an amount of work, and then have the spring launch something and have all the work in this, and then still have energy in the spring wobbling back and forth. I can't do that. That doesn't make any sense. I can't get 100% back plus wobble the spring. So we're back to, the simple 5 mass. I add 5 mass to it, make a 10 mass, okay, at half the velocity. So I have a 5 mass going 10. I convert it into a 10 mass going 5, and I've lost half the kinetic energy, even though I have all of the momentum. So how can I possibly have all of the momentum over here and make something fly off or make heat or generate some other work? Can't be done. Nonsense explanation. All right, so on to more recent arguments. Well, this argument's not very recent, but anyway, the fact that MGH is a fallacy, fake, phony, fraud, and MGT is the accurate definition of how gravity gives objects momentum, the capacity to do work, energy, in effect. And it can be visualized in a simple experiment. All right, that essentially is the same as the dropping experiment. You can take a same mass and change its velocity. Okay, so one mass going 1 velocity, one mass going 2 velocity, and you'll see this bizarre, outcome, frankly, where the 2 velocity object goes 4 times the distance. But what can be understood is it's only going half its speed 3/4 of the way down the track, which is the same as this. So this happens, in 1 unit of time. This happens in 1 unit of time. And this happens in 1 unit of time. And the simple argument is this just a friction argument. You could do this by pushing something. You drop something and you blow wind so it hits the surface as it's falling, and it will be rubbing against the surface. And the fact is, though, the faster it's going, the less the wind could affect it and push it into the surface per inch, the less pressure it will feel, because it's a time-dependent force. It's 9.8 meters per second over 1 second. This is also a 1 second. So it's obviously in second increments, in chunks, divided into timed units. It's clearly a time-dependent force. By their own formulation, it's obvious. So the fact is the 9.8 has to be spread over this entire distance, and the 9.8 is spread over this little distance. So obviously this weight is going to be more than this weight. Now the total is the same, but per inch it's going to be much less weight. So the faster something moves across a scale, for example, the less it will weigh. So if I could put a elephant on a rolling ball and have the elephant fly across a scale, the elephant will weigh less and less the faster I roll the elephant across the scale. Just an absolute fact. And that is because there's not enough time. If I took a chunk at this at twice the velocity, there isn't enough time. It's less time. It's not a second. Let's say if this was 1 second. This isn't 1 second. This is 1/3 of a second or whatever. It'll be less than that. Obviously, because it gets slower and slower as it goes. So it's going to be 1/4 of a second or something like that. So this is going to be a lot less time for the weight to apply its pressure, and it needs time to weigh its full weight. So if you make it go really slow, then it'll weigh its weight all the time. But the faster it's going, the less it's going to weigh its real weight. That is, it has to be going faster than the speed of gravity. So gravity obviously does have a speed. We put it in 1 second units because, well, that's what we do. But if we put it in some other unit, you wouldn't even need the gravitational constant because it would be in the right units. The only reason that there's a gravitational constant is to turn the 1 second units into whatever the universe's units are. So anyway, so that's the argument. And so they do these experiments where they're going to do the old Leibniz thing of dropping objects and claiming that they have more energy because they dropped more units of distance, that there was 1, 2, 3 units of distance, so that must be 3 units of energy, that the object gave the ground 3 units of energy. That's their argument. And it gave it 1 unit here. That's what they're claiming. When no, it only got 2 units. It only has 2 units of velocity. It only has twice the momentum. And the fact is it's just spreading it unevenly on this surface. Okay, it's very little friction here, and it gets more and more and more and more and more as it slows down. That's the truth of it. And so you can't, raising something 4 times in gravity doesn't give you 4 units of gravitational effect. It only gives you 2. It's only 2 seconds of time it takes to drop the 4 units of distance. And it's how long you're in the gravity that decides how much you're going to be moved by the gravity. And I have explained this one so many times. There's no counter argument. They'll produce nothing. That doesn't very helpful. Alright, so you have a gravitational body, you're going to fly by it. The fact is, the faster you fly by, the less you get bent. And the slower you fly by, the more likely it is you get consumed by the force. Okay, so the force is time dependent. And the faster you go through a force, just like spray paint, the faster you go through the spray paint, the less spray hits you, the less force affects you, the less paint you're going to have on you. It's just that simple an argument, irrefutable, undisputable, yet they dispute it and refute it with garbage, goofy rhetoric. They don't make any arguments. All right, so let's get to the most recent observation about how weight is absorbed. Alright, so again, this is part of the learning curve thing. A few weeks ago, I would have stated that, if you're going to do this experiment, that you would have to account for the static weight of an object. So let's say if I'm going to drop something onto a scale, I have to consider not only what its mv is, so it has an mv as a mass falling, a velocity, it's moving, just as if it was horizontal. And then I have to add to that the fact that, it's hitting the scale with a mass, so it's more than just its linear motion. It has actual gravitational weight that I would have to figure is part of its impact. And the fact is, it just isn't, because this motion is faster than gravity would accelerate an object. So the fact is the heavier the object I put on, the faster the spring is going to move. So the momentum, if the momentum is faster than the object you're adding, it's like having something going a certain speed, and then you're going to follow it with something else. I guess I have to draw it over here. That's going slower. It can't really add any, so you have something going 10 miles an hour, and then you have something trailing behind it 5 miles an hour. You can't have something trailing behind that's actually going to add to the impulse of that 10 miles an hour. So let's say I had a catapult, all right, and I pull it back and I've got it locked at a position, and then I put an extra 10 pounds on it. The catapult's not going to drop further down. Say I have 1,000 pounds of pressure on the catapult, so it's as if I put 1,000-pound weight on, then I lock the catapult, and I take the 1,000 pounds off, and now I put 10 pounds on it. It's not gonna have 1,010 compression. It's not gonna compress the catapult anymore, because the compression is always much greater than the mass's gravitational momentum. So it can't add any pressure because there's a huge reverse pressure. So as soon as you've created more pressure, that is, you go in with more momentum than the object can create, then you've already put more counter force in than the weight of the object. Therefore, it can't possibly add more compression because the force pushing back is much greater. So as long as this force is, say, 10 pounds going this way, and I'm trying to add 5, I can't add the 5 pounds because there's 10 pounds going the opposite way. And so the simple truth is that once the momentum pushes something down, the gravitational weight can't do anything because this force is already acting. The force pushing back up is already acting before the other force can do anything, before it can add anything or contribute. So if in the catapult example I didn't lock it and I put the 1,000 pounds on it and then I added 10 pounds, well then they'd both be moving the same speed and there'd be no problem. So you would have 1,010 pounds worth of weight on the catapult. But the fact that you have to recognize that impulse and static gravitational weight aren't the same thing. One of them is, and especially when you have it as just a stored force, you can't add to the stored force by adding something that has less momentum, less force. Something with more force has to push. Something with 1,001 pounds of force has to push to make the scale move to 1,000 and whatever. It can't do it without something much heavier pushed down on it. Something much lighter can't add any mass or any force to the compression. It's a simple argument. It's just saying that when you compress something, when you create an impulse, and on a rubber band, for example, you can't state that the static mass has anything to do with it because this velocity was much faster than the time gravity needs. And again, the thin ice argument is the one that kind of decisively proves the case, in the sense that the object weighs less per inch. All right, per any segment. I could just take any segment of the ice and I could just say, well, how long was the object on top of the ice? And how long it was on top of the ice will decide how much it weighed at that location. So the faster it's going, the less it weighs. And the fact is that it can't weigh anything if the impulse was much faster than the speed of the object itself would be falling at. And therefore the counter force the rubber band's already on the way up before the static weight of the object is even recognized by the rubber band. So it's again, this is real physics. They deny it. Okay, they ridicule it. They mock it. They mock this as an explanation. They mock this idea that thin ice, you can traverse it by increasing your velocity. They deny stuff that simple and obvious, that the truth is the reason why the ice doesn't break is because you're applying less pressure, because gravity has had less time to give you your weight. All right, because it's a time-dependent force. All right, so we'll read some of their dopey comments. So again, there was Brozo made a comment, and yet he has said nothing regarding this experiment he was supposed to do that he hasn't done. And you're just saying, what is that? Is there any explanation for that? So somebody have some explanation for why this weasel, who mockingly declared his victory before he even did the experiment, why has he copped out? All right, so this was some, I don't know, John Walker, Falwell, I can't tell the difference. Anyway, at about whatever time code, he did pick up him mailing his thin ice argument again. Maligning? I don't know what that is. But now it has subsequently changed. So I didn't change anything. So it's just idiotic. It's a simple enough argument. Whether you argue that gravity doesn't have enough time to give it weight, or you argue it's evaded having weight because it went faster than the gravity can affect it. What, you're just going to play a verbiage game? Where he has always stated the faster you move, the less gravity can affect you. Yes, that's exactly, so what is incorrect about that? That's exactly the point. So I go by a gravitational body, the faster I go by it, the less gravity will affect me, the less paint will hit me. Gravitational paint. Affect you because it doesn't have time. Okay, and so that's exactly what I'm saying today, and I said yesterday, and I said it 2 years ago. Today he states the gravity or the weight is spread over a much larger surface area. It's exactly the same statement. There's nothing different. The point is I've drawn it so many times. I used a little bracket and show 3 units of distance, only 1 unit of time. Obviously, it has to be spread thinner. I used analogies like spreading something on bread. You have to spread it thinner if you have more bread. A lower weight force per square inch or surface area. So that's always been the argument. There's never any other argument. Not that he's evading gravity now due to its velocity. Not that it's evading gravity now due to its velocity. So what else could it be evading gravity by? The only thing that can allow it to evade the gravity is its velocity. How else could it possibly be evading it? It's just such a bullshit argument. All right. Anyway, so this is why you can't have any serious debate or argument with Goofy. So this is the best they can do as an argument. So again, they can't honestly, without quote mining or some other bullshit, deal with my arguments. And instead they play these stupid, idiotic games, about verbiage. And if their statements are played back to him and countered, we are not supposed to quote what he actually says. I think quotes are great. So go ahead. Where do I find that? I didn't see any quotes here. So that didn't happen. And the simple truth is that, yes, you can. There's a thing called quote mining where you can take something where I said it the wrong way. I said electron instead of proton or some kind of dopey thing like that. And you can take advantage of shit like that. And that's all you've got as an argument. Because he didn't mean it that way. Apparently, it is a slippery snake in the grass. So this is such a bullshit. So these arguments are plain and simple. I've made them over and over again. Where can your counter argument be? Where's your argument that springs give all of their momentum to the object being pushed by a spring? Where's your counter argument that the angular rotation of the wheels is irrelevant? Where's your argument? Again, where did you ever even establish? I just presumed it. Okay. Did you do something other than just presume that the static weight can be collected? I mean, do you have any physics or science to prove that the static weight should be subtracted from its momentum? Yeah, no, you don't have any such evidence. LOL, Goofy reached a new pathetic level where he now comes up with excuses for why static weight compression or static weight stretch doesn't matter. So he says it's an excuse to point out what you can understand is obvious. That if I compress something with 1,000 pounds and lock it in that position where it's ready to be released, I can't add 10 pounds. 10 pounds won't register. Okay, we should not subtract the maximum compression with the static weight compression. Yes, that's the argument. I wouldn't have, like I said, even just, a month ago, I didn't see any problem with that. And now I realize it's just kind of obvious that the static weight takes a lot of time to be absorbed. The static weight, especially of a less heavy object that's going to move the scale, less deflection over less distance, is going to be not much. Yeah, it's not going to be happening at the same speed that the momentum is being collected. Let's see. We should not subtract the. Anyway, he wants to see horizontal collisions again. I just stated the obvious, that I guess it's better to have experiments where gravity isn't going to fuck up the experiment. So in like Brozo's lever experiment, it's done horizontally because now you don't have to worry about all this calculating about lifting something in gravity and all that nonsense. So yeah, it's better. Okay. And then he says, I've done the bloody dozens of times. So this is just a lie. He's done these shitty experiments, not ignoring the spring argument, launching funny shaped objects. No proof that he launches them horizontally. They could be flying up, they could be flying down, who the hell knows. Just the shittiest possible crap experiments. And he's claiming he's done something credible. Well, show me the credible one. This is a guy who crashes cars into fucking crackers. Okay, new level of patheticness indeed. Yes, that's what you're always reaching for your next level of jackass. And so just keep adding to the litany of evidence that you're not about anything other than your petty resentments. And there's nothing else motivating you. You don't give a shit about physics and the logic of it. The fact that it's a science and it has to do with this idea of a continuity, and you don't care. You'll accept wave particle, you'll accept kinetic energy versus a momentum duality, that somehow that could possibly make sense. There's two kinds of energy in the universe, momentum and kinetic energy, and you'll just decide whenever it's convenient which one to use. You're pathetic. Okay, so some other comment by some other asshole saying, new level of patheticness indeed. He seems to have lost sight of what he is arguing, which is not unusual. So just useless gibberish. So his claim is MGT gives correct answer every time and MGH is wrong and fable. Yes, that's a simple argument. MGH will not tell you how much energy something has. It's just nonsense. Velocity, momentum tells you how much energy something has, and it comes out in every fucking experiment. So the ballistic pendulum always conserves the momentum, never conserves the kinetic energy. The crash test always conserves the momentum, never conserves the kinetic energy. So no matter what test you do, including the lever launcher that Brozo has failed to do. He promised and he won't deliver. And he promised in a bold, mocking way, like he was going to ruin my day and he was going to give me something to worry about. And the fact is he did the damn fucking experiment and he can't break it. He can't find a way to cheat. And that's why he won't do it. It's because he can't find a way to cheat out of the truth it shows. He's just a lying, cheating, lying sack of shit. Okay. So the drop tests have been performed to verify which formula works. So we know that these drop tests, I mean, especially the Falwell garbage where he has a spring that doesn't even have a flat edge. The spring actually pops inside of the thing he's dropping. So it doesn't even hit a regular surface, and the spring actually jolts and pops inside of the weight. I mean, just terrible, awful. None of them done to calibrate anything. They don't put 25 pounds on the spring and see, because that's going to be the real weight, right? If you're going to drop, well, let's just say you have a 25 kilo weight and you're going to put that on a spring. Well, when you're going to drop it, you're going to double its weight when it's 1 centimeter, and then you're going to quadruple its weight at 4 centimeters. So you have to test it to see, well, if 25 kilograms does this, then I know 100 kilograms has to do 4 of those. All right. Today, the genius that is goofy states that it would be better to take gravity out of the equation. Yeah, if you're going to measure something's energy, the point is that, well, there won't be any dispute about linear motion. So how can we test MGT against MGH if we are not using gravity? We're testing the theory that momentum versus kinetic energy. And so clearly that test is that linear motion is 2 velocity, not 4 units of distance. So we know in the lever case it moves 2 units for 2 velocity. It doesn't move 4 units of distance. So we know that that's the difference, and that's the way we can figure out the truth. We know that 4 units of distance in gravity creates 2 units of velocity. We know that levers, it's only 2 units of distance that creates 2 units of velocity. So the simple truth is we know the two things have to be the same. That 2 velocity is 2 velocity. I can't. If I have a 2 mass going 2 velocity, it doesn't matter whether it's going this way or it's going that way. It has the same energy. Okay. So how can we test it? Blah, blah, blah. All right. A stroke of pure brilliance from the Gooster. Okay. So, yeah, obviously it's perfectly sensible to say if you think there's a debatable object about whether or not we have to account for the static weight, well, we take the static weight out of the equation and just duplicate the velocities. You agree that an object dropped 4 units of distance will have 2 units of velocity. You agree that will be the outcome. So let's just create 2 units of velocity horizontally and solve the problem. Also, we are now not to account for certain variables in these experiments. Static weight compression. Where did I say you don't account for them? My whole argument is I didn't account for them. I didn't pay any attention to thinking it mattered. And I've realized, of course, it matters. Well, usually he wants every variable accounted for. What's a hypocrite? So what's the hypocrisy? When I agreed with you that it doesn't matter because I didn't even think about it, somehow then I was doing good science. But when I thought about it and realized that, yeah, the real weight can't be measured by something moving much faster than the gravity can affect something. I mean, if the gravity takes a second to give something its mass, and that is a half second will only be half the gravity, and a quarter second will only be 1/4 of the gravity, that it's going to weigh a lot less, isn't it, moron? So if the experiment happens before the object can impose its weight, before it has enough time to impose its weight, well then obviously it can't be part of the experiment. The static weight can't be part of the experiment because the static weight needs so much time to be absorbed and there is no time to absorb it. Let's see, we now are in... Also now we are not to account for certain variables. Okay, yeah, that I read. Just say we did negate the static weight compression for the sake of argument in my example of the 25 mass and the 1V. So this example was just so bad. This is the experiment where the spring pops inside of the mass. It's just useless garbage. I mean, I won't even bother reading it. Just nonsense. A piece of absolute steaming shit. And again, we'll go back to Brozo. Brozo said, okay, look, my experiment was used as an example, and it's a proof, and it is a damn good proof on my side. There's just no doubt about it. 19 and 11 sounds a lot like 2 to 1. Okay, that doesn't sound much like 1 to 4. I mean 1.4. So, you know, that's your people, just, you know, their hypocrisy and duplicity in accepting experiments to go their way and not accepting all the experiments that don't go their way. So again, they haven't explained why the block experiments done by what the hell's his name? Bruce Yerney don't illustrate a simple truth that kinetic energy can't do work. That it can't show itself in a contest. It can't win a tug of war. I can have 100 times the kinetic energy on one side of a tug of war, and it doesn't matter. If they have the same momentum, the 100 times kinetic energy isn't going to make any difference. If I theoretically could tie a rope between a bullet and the recoiling gun, the fact is the bullet's not going to win. Truth. Now make your counter argument saying the bullet will. Somehow just make the argument and explain to me how the bullet will win, because it has 1,000 times more kinetic energy. All right. Because there's no evidence it'll win. Let's see. I already read that, didn't I? Yeah, I did. No, whatever. Okay, so that's it. I guess I should have put that on the screen or something. Sorry. But anyway, it doesn't really matter. You don't need to see the garbage. Yeah, so Brozo left a comment on Dispar's video talking about nothing. So there's just no explanation for where his experiment is. Like I said, he was promising he was going to do it, and he didn't do it. So he types, nice comeback, Q. If you want my comeback joke, you'll have to scrape it off your mom's teeth. LOL. So that makes more sense. I mean, the guy is such 1942. I actually liked the point he raised and was worth the effort to check, but unfortunately for him, it wasn't the easy answer he was hoping for. So I don't even... I mean, he's conceding that some of these mechanical systems, you should pay attention to these variables like the center of mass and different things. But anyway, at some point he will run out of things to nitpick. So where is your experiment? Again, let's nitpick your experiment. You're nitpicked it and say somehow it's catastrophically wrong, that you did the experiment so catastrophically badly to get those silly, awful results. So go ahead and show us the right way to do the experiment. And we'll just have to accept the harsh reality that, that he bet on the wrong horse. Well, you've done that. And again, if the future is to do me any honor, find this asshole's grave and piss the fuck on it. Alright. Because these are really rotten human beings. Typing this kind of absolute fucking rubbish. They haven't proven a goddamn thing, and they've denied their own experiments. Denying the outcome of their own experiments. Lying about the outcome of their own experiments. Again, he understood so little about this concept that he, he claimed, the experiment predictions were 12 and 16. So kinetic energy predicted 16, momentum predicted 12. He got 14 and claimed victory. I mean, you can't get more idiotic, right? I mean, he's got a complete noise answer, a completely useless answer, right in between the two choices, and he claimed victory. I mean, that's what a weasel this person is. They're all weasels. Again, the Dispar guy cheated the fuck out of the knocking things over experiment. Never did it the right way again, right? So once I explained to him his huge and catastrophic lie failure in not understanding how the experiment works, he never redid it. So, yeah, maybe I'll just draw that for the sake of it. And just, I'm pretty sure the video's still up. So he hasn't retracted it or annotated in any way, I bet. And still goes with the lie. The video's just a complete fraud and a lie. So he's testing two pendulums swinging. And one of them swings this far. Okay, that's its total arc. And the other one swings this far. That's its total arc. Alright, and so what does he do? He puts a mass here. Okay, so you gotta understand, this one has almost lost all of its energy when it hits, right? I mean, it's lost, it's 90% of its momentum is gone. It's decelerating, almost coming to a stop. This one, on the other hand, is still plus 90. Still got 90% of its momentum. The numbers probably weren't that outrageous, but it's the same idea. It's that it clearly wasn't a fair contest. You don't test the impact weight when it's completely almost decelerated. You have to test the impact as close to the peak velocity as possible, not as far away as possible. And that's basically what he did. He found a point far enough where one object has lost half its momentum and the other one has only lost, 20%. Complete cheat. All right, didn't retract it, didn't say, yeah, you're right, I fucked up, I did it wrong. And certainly didn't redo the experiment fairly, where you proportionally put the object to knock over at the same proportional distance from the peak velocity. If you're gonna cheat the experiment, then cheat it at least proportionally. But nope, didn't do that. Alright, so anyway, enough of the video. So it's just pathetic. Steve Mould, all these, nobody to sit there and basically argue that levers don't conserve momentum. I mean, it's a 1,000-year-old device. The only reason it has any use is because it does convert mv into vm, okay? Big mass, small velocities into big velocities and smaller masses, and it does it very well. And that's the mechanical advantage of a lever, is that it can give you a conversion of the energy into something slower or faster, something with more torque or less torque. And that's the advantage. All right. Anyway, God. Oh, people just suck. Push-averse. It's a suck-averse. Billions, hundreds of billions of neurons, and this is what these assholes do with them. Millions of years of evolution to get here. And this is what jackasses do with our big brain. Fuck.